What's up, everybody? Today, I'm here to gift you the knowledge of how to solve a delta epsilon proof. A lot of the videos on YouTube that I see are very complicated and require you to be a math wizard to understand. And I know this is a lot of your first introduction to proofs or anything like that. Maybe you're taking a Calculus 1 class, maybe you're taking discrete math, but regardless, I'm going to give you it in a way which is simple to understand and easy to replicate for you guys for your tests or just your general knowledge. So, to get into it, we have this limit, and this limit of 5x plus 7 is equal to 2 with x approaching negative 1. That's our problem. So, the first step in any proof is to state what you want to do. In this case, we want to find delta. This d right here is delta, or that d looking thing, so that when the distance between x and negative 1, which is x plus 1, the absolute value of it, is less than delta, the distance between the 5x plus 7 and the 2 is less than epsilon. This may seem very complicated, but I'm going to solve it, and you're going to watch, and you're going to understand what's going on by the end. There's also math language that a lot of your professors or other people online you might see. I'm just writing out what the words mean. There are more complicated ways, not complicated, easier ways actually to write those words, but just for simplicity, I'm going to write them out for you guys. So, yeah, that's our first step. We want to find delta so that when x plus 1 is less than delta, the absolute value of 5x plus 7 minus 2 is less than epsilon. If that is true, that means that this limit up here is true. So our first step before we actually get into our proof is we have to figure out what delta value we're going to use. So we take this 5x plus 7 minus 2, the absolute value of that, which is less than epsilon. Make sure you write that out. We take this value, and we're going to see if we could find an x plus 1 in there. If we can somehow manipulate it to find an x plus 1 in there, the rest of this problem will be extremely easy. So let's combine like terms. First things first, we combine the 7 and the negative 2. So we get 5x plus 5. The absolute value of that is less than epsilon. And then we can factor out a 5. So we have 5 times x plus 1, all in absolute value, is less than epsilon. Then because the 5 is outside of the parentheses but still inside the absolute value, we can take it outside of the absolute value, and then we're left with 5 times the absolute value of x plus 1 is less than epsilon. So the last step of this to figure out what our delta value is going to be is we're going to divide this 5 to both sides, and we end up being left with the absolute value of x plus 1 is less than epsilon over 5. Now that is pretty much the hardest work that you're going to have to do in these linear delta epsilon proofs. But we're not done. We haven't even started our proof, actually. So let's start our actual proof. But remember, this this epsilon over 5 is going to be our new delta value. So, when doing a proof, what we're going to do is first we're going to write suppose that. And here we're going to suppose that epsilon is greater than 0 is given. Let me fix that. Next, we're going to choose what our delta value is, which we figured out up here. This is our delta value. We're going to choose our delta is equal to epsilon over 5. And the last part to set this up is we're going to assume that x plus 1, the absolute value of it, is less than our delta value that we're choosing of epsilon over 5. The reason that this is true right here is because in our, up here, it says the absolute value of x plus 1 is less than delta. We just sub the delta. We sub the epsilon over 5 for our delta. So that's all that's going on there. Pretty simple to understand. If not, ask me in the comments. I'll help you out. But okay, so this is like the pre steps for our proof. Now our actual proof is we're going to solve and do a lot of the same math that we did before. We're going to try to get the absolute value of x plus 1 again, but with a slightly different step. I don't know why I wrote x there. With a slightly different step. So we're going to factor, just like last time. We get the 5x plus 5. And we can factor out the 5. Then we can take the 5 out. But this time, it's a little bit different. So this is where a little bit of we have to take a little bit of a jump. So up here, it says that x plus 1, the absolute value of it, is less than epsilon over 5. Over down here, we have a 5 times the absolute value of x plus 1. So if we know that the absolute value of x plus 1, in this case, is less than epsilon over 5, we can also assume that if we multiply 5 to both sides, that's the same problem. We're just multiplying 5 to each side. So therefore, 5 times x plus 1 is less than 5 times epsilon over 5. And if we simplify that, 5 times x plus 1 is less than just epsilon. That is basically the end of our proof. We just have to write, thus, 5x plus 7 minus 2, the absolute value of all that, don't forget your absolute values, is less than epsilon. So by proving all of this, or I guess this too, by proving all of that, we ended up proving that the limit that we were doing, or the distance between the limit, is less than epsilon, and that there is a delta epsilon proof. If you have any questions, let me know. I know I kind of went through it, but I tried to make it very simple for everybody to understand and able to replicate. So, yeah, you're not going to know this by just watching this video. You're going to have to do a bunch on your own. I always say do like 50 more of these and you'll fully understand it. And even then you might not. But the way you get better at math is by repeating it. You can't just watch YouTube videos. So, yep. Thank you for watching, and I'll see you later.